Welcome to Mobile Math lessons on the go. Today's learning goal: by the end of this lesson, I should be able to divide whole numbers by a decimal number without the use of a calculator. So a reminder, multiplication is a shortcut for repetitive addition. Division is a shortcut for repetitive subtraction. So a couple of notations. We're going to start our problems today with 10 divided by 2.5 or 2.5. So you can see there are various ways of writing that. So what does it mean? If 10 was divided into 2.5 equal groups, how many chips, counters, etc. would be in each group? Or we could also think of it as how many groups of 2.5 are there in a group of 10? Or how many groups of 2.5 can I subtract from 10? Hopefully one of those sentences means a little bit more to you in terms of solving the problem, but I'll try and show you multiple ways here to tackle this problem. So first up, case 1. If 10 was divided into 2.5 equal groups, how many chips, counters, squares, etc. would be in each group? So you can see on the left here I have 10 little squares. They're colored yellow, white, and blue. So if I start breaking that up into 2.5 equal groups, you'll notice that I end up with 2 groups of 4 and 1 group of 2. So when we read that, that's 2.5, 2 full groups of 4 and 1/2 of a group of 4, which is 2. So personally, I don't find case 1 to be the easiest way to think about this problem. Some people might like it. I like case 2 a little bit better. So how many groups of 2.5 are there in a group of 10? Well, if I look, I can break up my 10 into 4 groups. Each group has a full 2 units and then half of the remaining blue squares. So I can see that there are 4 groups of 2.5. I personally like that one a little bit better, but I have more ways to show this to you. We could also use our repetitive subtraction, and this might be the easiest way for most people to see this problem. If I subtract 2.5 repetitively, I could see that I have to do that 4 times. So 10 divided by 2.5 or 2.5 equals 4. Let's take one more look at it, and we'll do the group subtraction and long division in a minute. But before we can do that, we have to take a little look at equivalent expressions or equivalent fractions. So 10 divided by 2.5 or 2.5 is equal to 100 divided by 25. So what we want to look at here is if I multiplied both the top and bottom by 10, 10 times 10 across the top would give me 100. 2.5 times 10 would give me 25. And what I need to concentrate on is this piece right here. 10 divided by 10 is actually the same as 1. So I'm multiplying the left-hand side by 1. And if I do multiply the left-hand side by 1, I don't actually change the magnitude. And this is a big idea in math, a huge idea. We can actually change the appearance of a mathematical expression, but not change its value. And I've got that highlighted down here. We use that a lot in fractions. So the appearance of a mathematical expression can change while the value stays the same. So if you look at the left-hand side and the right-hand side of this expression up here, if we were actually to do the division, say on a calculator, we would find we get 4 and 4 as the result on both sides, even though the left-hand side and the right-hand side look different. So let's keep that in mind as we take a look at the next few examples. So group subtraction, 2.5 divided into 10. So I know that 2 groups of 2.5 is 5. So when I subtract that, I'm left with 5. I subtract another 2 groups of 2.5, and I have 0 remainder. I count up how many groups I have, and there's my 4 again. Now up in the right-hand corner here, I just have a little proportion just to remind ourselves what we're doing. We're going to multiply both top and bottom by 10. And the reason I choose 10 is I want to make the decimal place move one place or one location to the right. So when I multiply the top and bottom by 10, I get my 100 over 25. And then I can set this up as a long division problem, and I might be comfortable enough to say, hey, 4 groups of 25 fit inside 100, and I have my answer. So let's take a look at 17 divided by 4 and 25 100ths, or 4.25. So again, can I do this with a group subtraction model? Absolutely. I might be able to recognize that two groups of 4.25 would be 8.5. And if I subtract that from 17, I'm left with an 8.5. So I have two groups there. I'm going to subtract another two groups. I'll end up with a 0 remainder, and I still come up with an answer of 4. Now, that may not be comfortable depending on how fluid you are with decimals and subtraction. So let's take a look at the long division method. Now, in this one, I'm not going to multiply by 10 because I have two decimal places that I want to try and remove or simplify out of the problem. So I'm going to multiply the top and bottom by 100. Now that allows me to move the decimal place over 2 spots. And if you notice here, if this was where the decimal place started, it jumps over 2. This is where the decimal place started with the 17. If it jumps over 2, and we have our new expression of 1,700 divided by 425. Now, again, we could still do group subtraction on this method. We could do our long division on this method, whatever you're comfortable. But what's important here is notice the decimal places have been removed. So if the decimal places cause us some panic, we have a strategy that we can manipulate or change the problem to remove those decimal places. And then it's just like all the other long division group subtraction problems we've done. So if I look at this, and I'm going to do this with group subtraction because I think it's going to be easier to see it. If I have two groups of 425, that's 850. So that's two groups. If I subtract those, I have 850 left over, which shouldn't be a big surprise because you should see some similarities between these values here. Oops, up one. Here and here. And either way, 17 divided by 4.25, or 4 and 25 100ths, is still just 4. So let's put that into practice with something a little bit larger. So 25 divided by 3.125, or 3 and 125 1,000ths. So again, I could do this from a group subtraction method, but you can start to see how with these big decimals, group subtraction probably isn't going to be that friendly to us. So I could try it, but what I'm going to do is I'm going to focus my time over here on the long division, and I'm going to try and move my decimal place over 3 spots. So I have to multiply the top and bottom by 1,000 now, and that will help me move my decimal place over. Or the shortcut, 1, 2, 3 jumps. Start here with the 25, 1, 2, 3 jumps. It's the same as multiplying by 1,000. This is mathematically better to understand, but eventually the shortcut for a lot of people is they just count the jumps. So if someone explains it to you that way, you really know that they're multiplying by 1,000. So now we can look at how many 3,125s fit into 25,000. And again, I might do this with a group subtraction approach. I can look at the long division, but 3,125 doesn't go into 2,000. Yeah, it's going to be nasty. So I'm going to do this with group subtraction. So let's just start with something small. I'm going to have two groups, 6,250. And if I subtract that, I might have to borrow a little bit here. 4, 10, 9, and 10. So I've got 0, 5, 7. Oh, got to borrow some more. 8 and 1. So I have 18,750 left. So now I could see that 6,250, the two groups I originally subtracted, I could take a lot more away. So I might up this to 4 groups of 3,125. So I'm going to just double what I had previously. That's going to be 12,500. And now when I subtract those, it goes a little faster, and hey, look, I'm left with 6,250, which is what I started, so that's 2 more groups. And when I subtract those, I have 0 remainder, and I have a grand total of 8. So 3.125, if I divide that into 25, it goes into it 8 times. It's also the same as solving 25,000 divided by 3,125. Same thing. So the big idea today is we can move the decimal places around with equivalent expressions. That's a really big idea for making problems easier to see. Okay, if you could press pause on the video and try the following. So if you could divide the following, please. So please press pause now. Okay, welcome back. So let's have a look. First question here is 60 divided by 7.5 or 7.5. So you'll notice for the first one, I want to move my decimal place over one spot, so I'm going to multiply both values by 10. That gives me the effect of moving over one place with my decimal. So if I move over one place, my 60 becomes a 600. So the problem I need to solve is how many 75s fit into 600. That should give me the same result as how many 7.5s fit into 60. So I'm going to start with a group subtraction method. I'm going to look at 4 groups of 75, which I know is 300. And when I subtract those, I have 300 left over, which is another group of 4. And when I subtract those, I have 0 remainder, so I know I have 8 groups of 75 fit into 600. My next one, I'm going to have to divide 9 by 1.125, or 1 and 125 1,000ths. So I want to make my decimal place move over three locations. So this one I have to multiply by 1,000. So when I multiply my 9 by 1,000, the decimal place is going to move over 3 places, and it's going to turn into a 9,000. So the problem I need to solve is how many 1,125s fit into 9,000. So I'm going to start with 4 of those, and that's going to be 4,500. And when I subtract those, I'm left with another 4,500, which I already know is 4 groups. So I could subtract that again, end up with 0 left over, and again, my answer is 8. So for both of these, the answer or solution was 8. So thank you for watching, and if you could please watch again and pause where you may have had any difficulties, and good luck in your future math problems.